Good morning, good afternoon, or good evening, depending on the time zone that you guys are in. And welcome to this session on GMAT Algebra. In this webinar, we're going to talk about two topics specifically. One is linear inequalities in one and two variables, and then the second is absolute value. And my goal in this webinar is going to be to help you understand how to approach these questions, and then to give you feedback as to where you're lacking and the areas that you need to work on. It's a fairly application-focused webinar, even though we do start from the very basics. Our focus is on applying those basics overall. And to make sure that you guys are prepared for this, we did send a few video lessons your way. The video lessons in the top left corner are a few of the video lessons we sent your way. If you've not gone through these video lessons, log into your free trial. Just go to e-GMAT.com, click on login, and then go from there and make sure you go through them. Even if you're able to solve most of the questions in this webinar, I would still recommend that you finish your learning, you cement your learning by going through these video lessons, because they do have a number of examples as well as exercise questions. We also have some upcoming free webinars. We have a free webinar on how to score a 760 on the GMAT or a 740. And in this webinar, we start from helping you build your study plan to making you recognize what is important if you want to actually hit the milestones that your study plan has, and then how can you track your progress as you're putting in the effort to study. Then we have a free quant workshop. Think of this quant workshop as a proctored mock test in which we not only evaluate where you currently are in GMAT quant, but we also tell you, what should you focus on next to get to that next level of competence, whether it's going from a Q44 to a Q48 or a Q48 to a Q50. So again, both these webinars next week, and you can click on the register now button to register for them. Since it's a fairly heavily attended webinar, I do ask a few leading questions. One of them is, when do you plan to take the test? And the next one is essentially, where are you with regards to GMAT quant? So let's get a few more questions here. So this is the next one, which is, where are you with regards to GMAT quant? Okay. In the context of when do people plan to take the test? Testing's pretty much closed for the next 1 month or so. So very few people in the next 30 days or so. But a bulk of you, about 41% of you, have more than 75 days. Presumably, you haven't taken a date as of yet. With regards to where you guys are in GMAT quant, a good chunk of you are in that Q31 to Q40. Many of you are below that Q30, and then we have a few folks. A couple of you are in that Q49, Q50 bracket. Now, my goal really is, if you are in that below 30 to Q31 to Q40, I want to kind of make sure I make you recognize that acing GMAT quant is not as much about the math as it is about being diligent in applying the methods. And I want to make sure that in algebra, at least, for those of you who are weak, you get to above 60th percentile in these two topics, which is linear inequalities as well as absolute value. The other thing I want to impress upon is, these two topics, linear inequalities and absolute value, seem very difficult, but I want to make sure that you understand they're way more logic-based than math-based, at least in the context of the GMAT. And in other contexts, they may be more math-based, but when it comes to the GMAT, they're way more logic-based. So if you read them with an eye towards logic, then you're going to find that solving these questions becomes a lot easier. With that, let's go right into the webinar pane. And then as I go into this webinar pane, the screen will have changed for you. Pretty soon you're going to see Algebra Quant Live session. And let me put in a yes, no poll over here. The moment you start seeing this session, Algebra Quant Live session, select yes, so that I know, how many of you are actually ready to proceed. All right, pretty much most of you are. If you're not seeing Algebra Quant Live session, I would recommend that you join again. Usually when you do that, the system does reset itself and the um, problem solves automatically, or problem is solved automatically. This session is about 2 hours long. It's being recorded, so if you have to leave in the middle of the session, we will send the recording over to you, so don't worry about it. Um, with that, let me just go right into the core of this session. And so what's my purpose? My purpose, as I said, is to make sure that you guys get to that 60th percentile in linear inequalities and absolute value. So again, I'm not going to teach the basics. I'm going to make sure that I'm going to give a refresher of the basics. But then, if you need the basics, they are in the concept files. And then the focus is going to be towards the process of solving questions. And after each section. This session is divided into about 4 sections. After each section, I want to make sure that we note down the key takeaways. Now, talked about the concepts. We're going to start with a warm-up quiz. The purpose of this quiz is just to really give you a refresher. There'll be 6 problem-solving questions, and then we're going to go towards another 6 problem-solving questions, and we're going to end with 3 data sufficiency questions. So these 9 questions over here, just these 9 questions over here, these are going to be 600 to 700 and 700 level plus questions overall. Audio still good? Let me just do another audio test. Is the audio still good? Select yes if you find the audio is still good. All right. Thank you. Perfect. If the audio is breaking for you, if you're using a cellular internet connection, if you're connected using a cellular modem, then you're going to find that those connections vary in quality a lot. So that may happen. So with that, we're going to do a warm-up section. These are fairly easy questions. These are what I call as 500 level or even pre-500 level questions. The goal is to make sure that you are prepared for the more challenging questions. And these questions actually have 4 answer choices and not 5. So yeah, these are not, as I said, not really GMAT-like questions, but more questions that are built on fundamentals. So why don't you select still solving? And so I have about 120 odd students here in the webinar. Let's get about 50 people to select still solving. That way I'll get a good representation as to when you guys are done. That way I would not time you. All right, let's get about 50 people to say still solving. I still have just 39 people saying still solving. Has 10 more folks before I show the question. Yes, you can't see the question because I haven't shown the question to you. I need 10 more people to say still solving, or 2 more people now to say still solving. Cool. Here is your first question. Make sure you have a pen and paper. And now you should be able to see your first question. I'm going to mute myself. Pretty much most of you are done. I'm going to give you another 5 seconds before I show the next question. 3, 2, and 1. Let me end the poll. Let me broadcast the results. 70% of you chose choice B. Choice B is the correct answer. You're going to still show you the solution, so don't worry if you didn't get it right. Here's the poll for question number 2. Let's get 50 people to select still solving so that I can show the next question. All right, 3, 2, and 1. Let me end broadcast results. Here is the second question. All right, guys, most of you are done. Let's get those answers in. 3, 2, and 1. I'm going to end the poll. I'm going to broadcast the results. Again, choice B was the most popular answer. Let's go and do the third warm-up question, and then we're going to see the solutions to each one of them. Select still solving before I show the question. All right. 3, 2, and 1. Let me remove broadcast results. And here is the third question. All right, get those answers in, guys. 5, 4, 3, 2, and 1. Let me end the poll. I'm going to broadcast the results, and here what we see is we have a split here. Each, pretty much every choice is a reasonable number of people have chosen every choice over here. Now let me remind you, these are just basic questions, warm-up questions as we call them. That's why see the poll name as is WP. I'm going to start with the first question over here. This is how you guys polled in the first question. Choice B, about 70%, or pretty much everyone who polled, who responded, chose choice B. The question really said, what is the range of values of y if this inequality exists, which is 4y plus 10 is greater than minus y. And essentially, this is a question that tests your ability to solve an inequality. So how do you go about doing this? You actually really say, hey, I'm going to take this term minus y over here, this particular term, and I'm going to move it to the left side, which in other words, this is also adding y to both sides. And this inequality becomes 5y plus 10 is greater than 0. You move plus 10 to the other side. This becomes 5y is greater than minus 10, or uh, by dividing by 5, or plus 5 to be more precise, and you get y is greater than minus 2, which is choice B, which is your correct answer. And this is the most fundamental operation on inequalities. And if you have a basic knowledge of inequalities, this is where you apply this. Let's go towards question number 2, warm-up question 2. Warm-up question 2 built upon this. So this fundamental knowledge, we even extended it, and we had 2 inequalities over there. Again, most of you got got the correct answer, which is choice B. You're given 2 inequalities over here, and the question asks, what is the range of values of y if these 2 inequalities are true, which is x minus y is greater than minus 3 and minus 2x plus 3y is greater than 4. So what do? You really just take the first inequality, which is this inequality, and you multiply it by 2. Why? Because you really see, hey, over here in the second inequality, there's minus 2x. So if you multiply it by 2, you can cancel x out of both these inequalities. Okay. So when you multiply the first inequality by 2, you get 2x minus 2y is greater than minus 6. You can really see this is inequality 1. Let me just say this over here, 1 multiplied by 2. Then you add the 2 inequalities. When you add them, these 2 terms cancel each other out, which is, let me just put the annotation. These 2 terms cancel each other out, 2x and minus 2x. And what you're left with is y is greater than minus 2, and choice B is the correct answer. So many of you got this wrong, and so I want to make sure I ask you, why is it that, where did you make a mistake? Where did you make a mistake? I mean, many of you got this wrong. Only 57% of the class got it right. So didn't know that you could subtract inequalities. We are not subtracting, we are adding inequalities. You can't subtract inequalities. Okay, didn't know how to proceed. I copied. We did not multiply it by minus 2, Akshay. We multiplied with plus 2. Here is what you can really see. It's plus 2 over here. Okay. One of the problems with trying to plug in numbers is that you use it like a hammer to do it everywhere. And when you use it like a hammer, and if that hammer is not suitable for that kind of nail or that kind of problem, you end up messing things up. So that's really, really important for you to understand. Okay, if you copied it incorrectly, please make sure you copy it correctly. Don't make that mistake because you did all the hard work and then you still made the mistake. So what did we test? You want to make sure that you're comfortable in solving two inequalities, and you know that inequalities of this with the same sign. And when you say the same sign, you have greater than in both of these over here. That's the same sign. You can add those inequalities together. Here is a third question, and the third one, you guys made quite a few mistakes. I'm going to just clear this out over here. So essentially, you're given two inequalities. And the question says, and you have to read the question, how many non-negative integral values, okay, of m does the two inequalities satisfy? Again, you're given these two inequalities, minus 4m minus n plus 5 is greater than 0, n plus 5 is greater than 0, uh, and so essentially both of them have the same sign. So you add both the inequalities, and when you add both of them, n gets crossed out. What you really get is minus 4m is greater than minus 10. You actually added this and took 10 to the other side. So 5 plus 5 becomes 10, and when you take 10 to the other side, it becomes minus 10, which means if you did this, 4m is greater than 10, you actually made a mistake. Why? Because, hey, you can't really multiply an inequality with a negative number and not change its sign. That would be wrong. So when you multiply it by minus 1, you change the sign of inequality. So you look at what the sign is, it's greater than. Here again, because you multiplied with a negative number, which is the operation over here, you get 4m is less than 10, means m is less than 10 by 4, which means when you think about non-negative integral values, 0, 1, and 2 are non-negative integral values. And so the correct answer really is choice C, which is that there are three non-negative integral values. What if the equations have different inequalities, or don't call them equations, call them inequalities? What if the inequalities have different signs? You actually multiply one of them with a negative number to equalize the signs. So the answer is a total of 3 values. Okay, guys, if you have a question, please put your question in the Q&A pod, which is the pod which is below the presentation. Okay, so why did you make a mistake? That's what the short answer pod is. The two concepts that are tested, which is inequalities with the same sign, can be added together, which is the concept that we tested in the prior question as well. The second is the sign of inequality changes when you multiply it with a negative number. How come 0 is not a non-negative integral value? It is. That's why you see m is equal to 0, 1, and 2. That's why the answer is 3. Did not count 0. Could I please explain the sign change in inequality again? When you multiply an inequality by a negative number, in this case we are multiplying it by minus 1, you have to change the sign over here. So if you observe over here, the sign of inequality is greater than, and over here, once we multiplied it by a negative number, the sign of inequality is less than. So that's called changing the sign of an inequality. Okay. And again, the thing that I want to make sure you understand is this: the math here is very simple. It's about knowing A, knowing the concepts, and B, just thinking about it logically. Some of you did not understand it was what non-negative integral value meant. Others ignored 0. And again, this is where the math is not failing you. Your what shall I say, lack of good habits is failing you. All right. Ganeshwar is saying 0 is neither positive or not negative. Still, 0 can be considered as a non-negative? Yes, because it is non-negative. It's not negative. Ganeshwar. And again, if you were a critical reasoner, and that's kind of where if you understand critical reasoning, that's the same negation skill that you're bringing over here. When you say something's not negative, which means it can be a neutral value and it can be a positive value. That's what something not negative mean. All right. Let's go there. So again, these are very basic questions. Write down the mistakes that you're making, and then we're gonna talk about them and later on. And we want to make sure that we make, we reduce these mistakes and we help you get to that 70th percentile, 80th percentile, 90th percentile score. Okay. We're gonna go towards question number warm-up question number 4. Remember, there are 6 warm-up questions. Let's get to still solving. Excuse me, guys. And again, in these warm-up questions, the depth of solutions that I'm going to, the detail that I'm going into is very, very little. Why? Because we expect you to know these questions. As we go into the 600 level questions, you're going to see me discuss them in way more detail over there. Okay, I want 50 people saying still solving. I have 140 people in the webinar right now. Can I get 50 people to say still solving, please? 49, 50. I have 50 plus people saying still solving. Here's your question number 4. All right, guys, 80% of you are done. Let's get those answers in. 3, 2, and 1. Let me end the poll. And I'm going to broadcast the results briefly, and then we're going to go towards our next question, and then we're going to discuss question numbers 4 and 5. So broadcast results still solving. Let's get 50 people to say still solving. That way I time you guys. 24, 43, 44, 49, 50. Perfect. Thank you, guys. Here is the next question. All right, guys, get those answers in. 3, 2, and 1. Let me end the poll. Broadcast the results. Choice C is the most popular choice. So let's discuss questions 4 and 5. I'm going to put in the short answer poll over here so that you guys can tell me where you made a mistake. Excuse me. So question 3 said, hey, what is the range of this inequality? The first thing that you observe when you look at this question is that's a product of two numbers. Okay, x minus 2 is multiplied by x minus 3. And then the second is the product needs to be positive. So the way you go about doing it, and again, choice C was the correct answer, is that you can say, hey, the question is asking when is it that the product of two numbers is positive, greater than 0 is positive. Yes, you can do the wavy line method. I like the more fundamental approach. And there are two ways when they can be positive, which is one is when both x minus 2 and x minus 3 are positive, and the second is when both these expressions are negative. Why? Because product of two positive numbers is positive, which is this side over here, and product of two negative numbers is positive as well. So I kind of figured out when are both of these positive and when are both of these negative. So both of these are positive when both x minus 2 and x minus 3 is greater than 0, or essentially when x is greater than 3. And both of them are negative when both x minus 2 and x minus 3 are less than 0, and essentially which means that x is less than 2. So what is the range of x for these values? It's from 2 to minus infinity with 2 not being included, and 3 to plus infinity with 3 not being included. And that's where you get choice C. Okay, you can use the wavy line method, and yes, if you want to know what the wavy line method is, I'd be happy to give you an article. It's probably one of the most popular articles on wavy line method. It's also a part of our course. If you go through the video lessons, you'd be able to get it. Where did you guys make a mistake? A lot of people chose choice A. Why did that happen? Why did you choose choice A? Where did you guys make a mistake? Did not know how to execute. Now, does it make sense now when you look at the solution as to how to execute? Okay, perfect. Any other reason? Forgot that the question is asking for range. Okay, very good. How do you combine the equations? Okay, that's a good question. Let me just pause this. So the question is, how do you combine both equations? You really look at this and say x is greater than 2 and x is greater than 3. And the right way of doing it is to put them on number line, and you really say, hey, over here x is greater than 2, over here x is, so which means, let me just write down 2 over here. 2, and place it right next to this. X is greater than 2 means that it's 2 and this side over here. And x is greater than 3 means that it's 3 and this side over here. And the more stringent one is the one that you take. So that's why you combine those equations, and you really say the most stringent constraint is x is greater than 3. Similarly here, the most stringent constraint is x is less than 2. So that's kind of your range. Miss the possibility that two negatives also make a positive. Again, it's logic. In my opinion, that's not really like doing the math overall. And again, this is really important that you do this. All right. This is the wavy line method, by the way, that you can really do. Again, if you don't know this, don't worry about it. If you know this, you probably can see and read this fairly easily. Question number 5. We had more people making a mistake over here. Let's kind of go to question number 5. What's given over here is you have this fraction x minus 3 divided by x minus 4 is negative. One of the things that you should really see is how I'm reading this. I'm saying, hey, this is a fraction. That's the first image that should come to your mind. And then you say, okay, this fraction is negative. Is less than 0 means it's negative. When you start reading math as English, life becomes a lot easier in the context of the GMAT. In general, in the context of solving math questions. So if you start reading x minus 3 divided by x minus 4 is less than 0, it's a bit more complex in your mind. But if you really say a fraction's less is negative, then things start to become a bit more simple. Uh, okay. Now the question really is, hey, that's a fraction, and and um, and you say, can I multiply both sides by x plus 4? Yes, yes. Thank you, Gopi. It's x plus 4, not x minus 4. My bad. Can you multiply both sides by x plus 4? And the answer to that is not really. Why? Because x plus 4 could be either positive or negative, and hence you can't multiply both sides by a number that could be either positive or negative. Why? Because if x plus 4 is positive, then we don't need to worry about changing the sign of this inequality. If x plus 4 is negative, then we do have to. So clearly we can't multiply both sides by x plus 4. But how about x plus 4 whole square? Why? Because in the context of the GMAT, square of a number is always positive. So that's something that we can do. We can multiply both sides by x plus 4 whole square. And as you do that, what starts to happen is this fraction over here suddenly now changes into this inequality. Why? Because the denominator x plus 4, the x plus 4 in denominator cancels one of the x plus 4s in the numerator. Is everyone there with me so far? All right, perfect. Now it's very similar to the prior question. Okay, you use the wavy line method, and you use the same constraint method that we used in the last question, and what we find is that that it's negative in this range of -4 and 3, and outside this range, if you take any number, uh, uh, you can you'd find that it's positive. So the range is -4 and 3, both exclusive, not inclusive, but both exclusive, and which is where you get choice C as the correct answer. Okay, where did you guys make a mistake? Because a number of you did make a mistake over here. Where did you guys make a mistake? Did not get the idea then. You multiplied it by x plus 4. Okay, not x plus 4 whole square. If you took individual cases, it became very complex. You thought that the range should be towards infinity. Not necessarily. It's the question is asking again. That's where when you read the stuff in English, it becomes a lot easier. What it's saying is, for what valid values of x is this inequality satisfied? Okay. And again, now you can see, on the GMAT, you won't have like a ton of cases. You'd have a very logical set of cases. And even as you get towards those 700 level questions, what you're going to find is, yes, the math will get slightly complex, but it'll be way more logical than what these are. It's going to be more logic than math. Okay. Um, so if you have questions, you can put them in the Q&A pod. But now we're going to go to our question number 6. Which is our last warm-up question before we start solving real questions. Again, these are questions that you should know answers to before to get into this webinar, or you should be comfortable solving these questions. So warm-up question 6. Let's get 50 people to still solving. 5, 4, 3, 2, and 1. Let me remove broadcast results. Okay, here is your next question. Good luck. All right, pretty much everyone's done. Let's get to it. 3, 2, 1. Let's end the poll. You guys did the best in this question. 71% of you got this right. That's wonderful. I'm so proud of you guys. So, so there are two ways of doing it. One is you really just substitute values and you get to it. The more scalable way, the way you do it if you were to actually worry about not just solving this question, but even more challenging questions is to really say, hey, let's substitute x plus 3 as z, which means this is absolute inequality reduces to z is less than or equal to 5. And you visualize this on a number line and you really say, hey, these between -5 and +5, where -5 and +5 are both included, there are 11 values that z can take. So it can go from 0 to +5, or it can go from 0 to -5. And so this inequality becomes z is equal to -5 less than equal to z. So z is greater than or equal to -5 and less than or equal to 5. You again replace z back as x plus 3 and you solve for it and you get it as -8 less than equal to x less than equal to 2. And essentially, which is your choice C, which is 71% of you got this right. A few of you who didn't get this right, you can really see this over there. If you feel that you're having trouble, I'm going to share this PDF with you so you can work the math out and then really see where you made a mistake. But pretty much most of you got this right, so I'm not going to spend a whole lot of time discussing these questions. So again, this is how Z would look on the number line with both 2 and -8 inclusive. Again, 11 values over there. The very fundamental concept in absolute value or absolute inequalities overall. Okay, there's another way of doing it, but again, the thing which is really important is that you've got to ensure that you have absolutely 200% clarity in concepts. And if you faltered on these questions, I want to make sure that if you're an e-GMAT student, you revise some concepts from the course. If you're not an e-GMAT student, make sure you take a look at the free trial so that you get a grounding in this. Because as we move forward, we're going to increase the amount of application that we're going to do. We increase the amount of logical thought process that we do as we proceed towards 600 level questions, as well as from there on 700 level questions. Um, Again, if you faltered on these, make sure you go through these topics. They will be a part of your free trial in the next 12 to 13 hours or so. So log into the e-GMAT account, go through inequalities basics, go through inequalities basics practice quiz, and linear inequalities in two variables, which is kind of where a majority of those who faltered, a majority of those who faltered in these areas as well. Another thing that I want to kind of make sure you understand is this is just one of 8 modules in GMAT Algebra in the paid part of the course. So in terms of the comprehensiveness, you can see this way more comprehensive. Each of these modules has multiple practice questions and assessments built in there. So with that, let's start going towards more 600 level questions. And again, our focus will be on essentially making sure that you guys are able to solve questions and we note down where and why you make a mistake. So let's get to our standard way. Let's click on still solving. Let's get 50 people to say still solving. 43, 46. We have more than 50 people. Some of you choosing other choices without taking a look at the question. Here's the question. All right, guys, about 80% if you're done, let's put those responses in. 3, 2, and 1. Let me end the poll and broadcast the results. So 55% of you got this correct. Choice C is indeed the correct answer. But what's interesting is folks who've chosen the incorrect answers and the pattern that I see over there. So let's see what's going on. The question is asking what's the range of x if this inequality is there. What is this inequality? 16x plus 32 is greater than 48x plus 96. Okay. So what's given? You're given 16x plus 32 is greater than 48x plus 96. And what you have to find, you've got to find the range of permissible values of x. And you say, hey, is there a constraint on x? No, there is no constraint on x over here. Because since there's no constraint, you can start solving the inequality. You start rearranging the terms. You bring all the terms with x on one side. You take on all the terms with pure numbers on the other, and you get this is the rearranged inequality. Then you solve further, you get minus 32x is greater than 64. Okay, you multiply with minus 1 on both sides. Remember, when you multiply with minus 1, you change the sign of inequality. If you don't change the sign of inequality when you multiply with minus 1, this is what you do. You get 32x is still greater than minus 64, and you get x is greater than minus 2, and which is where you make a mistake. Okay, in that case, you get x is greater than minus 2, and you choose choice B, which is what 10% of you've done, which is minus 2x and plus infinity. But, or you choose choice A as well. Why? Because you really don't go towards plus infinity, you only go towards 0 in that case. But if you do it right, you change the sign of inequality. You can really see from here it was greater than, we multiplied it by minus 1 on both sides. We changed the sign of inequality over here to less than 32x is less than minus 64. You get x is less than minus 2, which means x is between minus infinity and minus 2, which is the correct answer. Okay. Most of you got it right. 54% of you got it right, but those of you who did not get it right, where did you make a mistake? This is a 600 level question, yes. Where did you make a mistake? Did not change the sign. Okay. With the sign, all right. Didn't flip the sign. That's really important. Tell yourself, when are you going to change the sign? When you multiply an inequality with a negative number. Algebraic operations, you made a mistake over there. Again, write them down. Do them slowly. You can see the visualization on the number line over here as well. Why should you flip the sign? Understand the fundamentals and an introduction to inequalities concept file. You'd really get to know why should you flip the sign. I don't want to go there right now because most people don't need that over here. And that's where, going through a self-paced learning course is beautiful. Why? Because it can adjust, it can adapt itself to your needs. But the takeaway is always change the sign of inequality whenever you multiply it by a negative value. All right, let's clear all answers. We're going to go towards the next question. The next question is going to build upon this. So don't forget this one. Let's go towards still solving. 50 people still solving. 41, 43. Let's get to 50 people saying still solving, guys. 48, 50. Cool. Here is your next question. Right, pretty much everyone's done. Let's get those responses in. 3, 2, and 1. Let me end the poll. I'm going to broadcast the results. When I see this data, I feel really sad, and I'll tell you why. Because those of you who chose choice A did the math right. Where you faltered was you didn't read the question. Please read the question and tell me where you guys faltered. Okay. It's supposed to be an integer. And is minus 5.5, is that an integer? No. The correct answer is minus 5, which is choice B. About 30% of you got. But those of you who got to minus 5.5, you guys did the math. You did pretty much all the steps, barring that one step, which is reading that the question's asking for is integer x. Man, that's a lot of work that you did, and you did well. Okay. Let's kind of see how we go about solving them just for the benefit of others. I mean, this is a difficult question. Now, when I compare this to how you performed in the first part of the webinar, you have improved tremendously if you got to minus 5.5. But man, because of that one bad habit, despite that improvement, you still got this wrong. Because I wouldn't have expected that many people to get to minus 5.5. But you guys did. So what's given over here is you're given these two inequalities. The first one is the same that we had in the prior question. We have this new inequality, which is the second one, which is 17 plus 3x is greater than or equal to x plus 6. And the question is asking, what is the minimum value of integer x? So is there a constraint? Yes, x is an integer. That's something which is a constraint, and we have to find the minimum value of x. Now I want to pause over here, and I want to impress upon you how this information is organized over here. you know, given, to find, and then the constraint. Doing this is about inculcating good habits. If you inculcate these good habits, you don't make the mistakes that you typically make. Why? Because most of you did the math right. Where you made the mistake is the constraint. Okay. So the first inequality we know, the range of values of x is less than -2. That's something that we did in the previous question. Let's just focus on the second inequality. You solve the second inequality again, you get 2x is greater than or equal to -11, which means you divide 2 by both sides. You said x is greater than or equal to -5. So on one hand, you have this, which is one constraint that you have is x is less than -2, okay, which means you're looking at the left side of -2. On the other hand, you have x is greater than or equal to -5.5, which means you're looking at the right hand side of -5.5. And and essentially, what you really get is this particular range, but you really say, hey, what's the minimum value over here? That's an integer, and that's where you zero it down to -5. Okay, the three possible values, -5, -4, and -3, and the minimum value is -5, which is choice B. Okay, someone went up to -3. You guys didn't realize -5 was smaller than -3. Others didn't consider the word integer. Really, really important. And again, knowing the constraint and writing down what's given and writing down what you have to find is really important if you want to minimize such errors. If you have a question, Drew, please put the question in the Q&A pod and I'd be happy to respond to it. Now, from this question, we're going to go towards quadratic inequalities in the next poll. And we're going to solve two questions, one after the other. Okay, so we're going to solve two questions and I'm going to actually put this over here. Now, these two questions will look difficult, but if you think about them logically, you're going to find that they're fairly simple. So before I get to the first question, click on still solving. Okay, I want to get 50 people saying still solving over here. I have 42, 45, 48, and I have 50. Let me remove broadcast results. Here is your next question. Here's the next question. Good luck, guys. All right, let's get those answers in. 3, 2, and 1. Let me end the poll. I'm going to broadcast the results, and what we have is what I call as a split jury. The choice A was really popular, choice D is very popular. We're going to really see which one's correct. Um, but let's go towards a next question. We're going to do these two questions back to back. Let's select still solving. I want to get 50 people to say still solving. Okay, here is your next question. Good luck, guys. All right, pretty much everyone's done. Let's get those responses in. 3, 2, and 1. Let me end the poll. I'm going to broadcast the results, and you can really see choice C is the most popular choice. Choice D is popular, so is choice B. Let's kind of look at the answers over here. Here is how you did the first question. Here's how you polled over here. I'm going to go back to question number 3. What's given over here, and I'm going to also bring in my short answer pod over here. What is the range of values of z square? And again, remember, we're not asking about the range of values of z. We're asking about the range of values of z square given a product of two numbers is negative. This inequality is a product of two numbers, and it's negative. It's less than 0. Okay. So given z square plus 4 multiplied by z square minus 2 is less than 0. So what you really say is, hey man, let's kind of figure out, and we have to find the range of values of z square. And writing this down is really important so that you don't go into the range of values of z. And if you did go into that, you're going to be choosing choice E, most likely in that case. So again, if you did not worry about z square, that's when you went towards choice E. This is a 600 level question, not a sub 600. This is a 600 to 700 level question. Okay, so you solve this inequality, and you really say, hey, z square plus 4, can this ever be negative? In the world of GMAT, z square is always positive. It's always greater than or equal to 0. I shouldn't say it's always positive. It's always non-negative, which means z square plus 4 is always greater than 0. So essentially, this becomes a fairly simple inequality where you say, hey, z square minus 2 is negative, which means z square is less than 2, which means z square is greater than or equal to 0 and is less than 2, which leads us to choice D. Now, where did you guys falter? Where did you guys falter in this question? Fairly simple. Okay, calculated for z, forgot about the square rule, didn't put in the constraint. One of the most important things, as I already say, it's about inculcating those good habits. When you think about z square, right? And or when you think about a question and think about constraints, you have to look at constraints that are explicitly given. You also have to look at constraints that are implied. Akshay says he substituted z square with x. Akshay, that's fine. You can substitute z square with x as long as when you convert x back to z square, you have to make sure you understand that z square, a square of a number, is always going to be positive. Okay, you can substitute z squared by x as long as you put in the constraint that x is always positive. You can't forget that x is that x is the only values that x can take are equal to or greater than 0. Okay, uh, and that's really important. Again, not the math, but just putting in the constraints. Just good habits is where you faltered. And again, it's not a rule. It's just a simple math, because on the GMAT you only have real numbers, no imaginary numbers. Hence, the square of a number is always non-negative. Okay, let's look at the next question and let's kind of see how you polled for the next question. You just get in the poll for the next question. Here is how you polled for the next question. I believe choice C is the correct answer, but let's kind of really see again. What's the constraint? The constraint given to you, and let's just clear all answers over here. What's the constraint over here? Can you tell me? Z is an integer, yes. And we have to find the number of values of z square, not z, but z square. Okay, and if you forgot, if you constraint z is an integer, so you say, hey, z square has to be between 0 and 2, which means that z square can have two values, which is z square could be 0, z square could be 1, z square cannot be 2. Why? Because once z square becomes 2, this inequality, it doesn't get satisfied. Why? Because then it becomes equal to 0, not less than 0. Okay, since z square can have two values, 0 or 1, and yes, 0 is an integer, the correct answer is choice C, which is 2. Okay, where did you make a mistake? Didn't count 0 as an integer. Minus 1 square is also 1, but can z square be minus 1? Can z square be a negative value? Can z square be a negative value? Forget about the values of z. That's not what the question is asking. The question is asking how many values of z square. Forget about z. Look at what the question is asking. Okay. Why are we not looking at z square plus 4? Because that's always positive. So it has no impact on the inequality. It's like k multiplied by z square minus 2, where k is a positive number. Okay. Didn't read the question. Did not think about z square. Again, you can really see it's not about the math. It is about the logic. You overthought. You first said, I'm going to figure out all the values of z, and then I'm going to look at the values of z square. Why? with the language trick. That's what the GMAT would do. It won't test you on the math, it will test you on the logic, because essentially managers aren't supposed to do a lot of complex math. They are supposed to think logically. Megan is asking, is there a calendar that shows all the webinars in the coming months? Megan, good question. We can definitely give you a calendar. You can send an email to rajat at e-gmat.com. Be happy to send a calendar to you. Okay. So what did you learn from this question? I mean, was this question difficult from a math perspective? Was it difficult from a math perspective? No, it was very, very simple. I mean, if you compare this question to one of the fundamental questions that we did, it's actually very, very similar to that with regards to the math. So what did you learn from it with regards to the takeaway points that you would have from this question? Think about constraints. Okay. Read the question well. It's one of those things which is very interesting is, I mean, I've been saying that on the verbal side of webinars again and again and again that, hey, if you want to do questions quickly, read the question stem slowly. In RC, if you want to solve a passage quickly, spend more time on comprehending the passage. Okay, do this, inculcate those habits, and you're going to find improving on GMAT Quant becomes fairly easy. By the way, we'd be releasing a bunch of lessons on our YouTube channel. So if you have not subscribed to our YouTube channel, do that, and you're going to find that over the course of next 1 week, we will be releasing quite a few lessons over there. So I'm going to show all questions, and I'm going to you're going to see the YouTube channel come up in the Q&A pod right now. Here's the link. If you just go towards actually, let me just put it in the notes pane, because since you're asking about good habits, we'll be sharing close to 35 videos on GMAT Quant. Actually, that's the wrong link. This is the right link, my bad. If you just Google e-GMAT, this is the right link. And this over here. Okay, before we move on to the next question, here is an overview of questions 1 to 4. The first question had a very, very basic application of inequalities, linear inequalities. The first two questions, linear inequalities, and what we tested was that in the first question, you change the sign of inequality when you multiply it with a negative number. Question 2, we also had two inequalities, and again, the same concept. Again, we started looking at constraints in question 2. There were implied constraints where we said minimum integral value, and many of you did not worry about the integral part, and then you chose minus 5.5 when you should have chosen minus 5. Some of you didn't worry about the minimum part and you chose minus 3. Questions 3 and 4 were about implied constraints, where we said a perfect square in the context of the GMAT is always non-negative, which means it is equal to 0 or it's greater than 0. Okay. We did some of wavy line method, but we didn't worry as much about it. You don't need to know wavy line method. That's something that I always recommend learning the fundamental approach first and then moving on to the wavy line approach if needed. Okay. Starting from question 2, we started focusing on constraints. Question 2 had an explicit constraint where we said z is an integer. Question 3 and 4 had implied constraints over there. And again, in question 4, we had to find the values of z squared, not z. Again, reading the question stem properly. Really, really important. Again, write these things down. These are habits. These are not things that, um, you know, uh, we sh these are not areas that you'd be making a mistake, especially as a manager. Okay. And it's really, really important that you take this down. You don't make these mistakes. All right, 50 people. We're going to go on to the next question. I want 50 people to say still solving. 5, 4, 3, 2. Let's get 50 people to say still solving. Perfect. We're going to go towards 700 level questions now. I'm going to move this out. And here is your first 700 level question. Requires a bit more solving over here, but no new concept. Read the question stem properly, understand what the question is asking, then go towards solving the question. You'll have ample time. All right. Go slow, but don't make mistakes. All right, most of you are done. Let's get those answers in. 3, 2, and 1. Let me end the poll. And I'm going to broadcast the results. All right. 35% of you chose choice E, which I believe is the correct answer. Very few people chose choice A, which I'm really happy about. Why? Because usually I've seen people choose choice A, and they forget the fact that the question's asking for minimum possible value. What's the positive difference? I'm sorry. People forget that, but now the fact that very few of you chose choice A tells me that that you really read the constraint well. So let's kind of look at this over here. So what's given to us is that we're given two inequalities, and these two inequalities, the first thing you have to observe is that they have differing signs. One of them is a greater than sign, the other one is a less than sign over here. Okay, so the first thing when you see something like this is to express these inequalities in standard form. All right, that's something which you should really say. And then you ask yourself and you say, hey, what's being asked? We have to find the positive difference between the minimum value of x and the minimum value of y. We have to find the positive difference between them. Okay, just a good yes no poll. Audio still good? Is the audio still good? All right, it seems the audio is pretty good for everyone. That's wonderful. Thank you very much. So, is there a constraint? Yes, there is a constraint that x and y are positive integers. Now, how many of you did all of this so far? Notice that there was a positive difference that needed to be calculated between the minimum possible value of x and minimum possible value of y. And how many of them noted all the constraints? Good. I'm really happy to see that. And again, the results show that. Thank you. All right, so the first step, as I say, is because these inequalities have different signs, we're going to express them in the standard form. As we express them in the standard form, the signs become similar. Then we solve, identical, I'm sorry, not similar, identical. Then we solve the inequalities, and then we find the answer. We kind of put in the constraints, and we really look at what the author is asking us to do. So you look at inequality 1, this is the inequality 1, and this is the standard form of inequality 1 over here. Then we do the same thing with inequality 2, and again, you know, we do this, and again, you see the sign is less than 0, so we multiply this by -1 to make the sign greater than 0. As you multiply it with -1, you convert it into the standard form where the sign is greater than 0. So what's the standard form? The standard form of inequality is ax plus by plus c is greater than 0. That's kind of that's the standard form. Okay. Now you have both the inequalities in standard form. They have the same sign. Both of them have a greater than 0 sign. You can do mathematical operations on these inequalities. Okay. So you say 1 and 2. What do? You actually multiply 1 by 3y because you want to get 3x over here. Okay, and as you do this, you cancel x out. By adding 3 and 4, and you get y is greater than 6. How many of you were able to get to this? All right, quite a few of you were. Perfect. Then you add 5. This is 5 over here. Y minus 6 is greater than 0. And then this is 2 over here, which is our inequality in standard form. And you add 5 and 6, you cancel y out. You get minus 3x plus 24 is greater than 0, which means x is less than 8. Okay. So as you do that, you ask yourself, what's the minimum possible value of x, and then what's the minimum possible value of y? So the minimum possible value of x is 1. Minimum possible value of y is 7. Remember why? Because both of them are positive. And then the positive difference between the minimum possible value of x and the minimum possible value of y is 7 minus 1, which is 6. If you chose choice B, you took the maximum possible value of x and the minimum possible value of y, and that's when you would get 0. Okay. Where did you guys make a mistake? Okay, I think you guys have written down. You made a mistake while solving the inequality. Yes. Call it inequality. It's not an equation. Can we think of x plus since? All right. 6x minus 6 is equal to 4x. Okay, that's what you did. Finding the minimum values, chose 0. All right. Missed the constraint. Okay. Some of you made a mistake while doing the math. Others made a mistake while choosing the constraints. And again, you can really see we are starting to get better. We're starting to get better, and as we solve more questions, we will be able to get better. But again, throughout this webinar, do you feel you've gotten more and more comfortable with these topics? Okay, perfect. Thank you. And that's what I want to do now. Some of you said we want to go towards some data sufficiency questions. We are going to go towards some data sufficiency questions, uh, and 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 um, and we're going to start with absolute value questions over there in data sufficiency. Okay. Now the thing over here is, as you go towards absolute value questions, you're going to find that the questions seem difficult, but uh, but the questions by themselves are not. If you start to solve these questions using logic, you're going to find that, uh, that solving these questions becomes really, really easy. Okay, so here is where we're going to go towards absolute value questions over here. And again, I'm going to share this PDF with you. So if you have a question about any of the steps, then you can always refer to it. The PDF outlines it very, very clearly. All right, still solving, 50 people. Let's get there, guys. Because now we went really, really deep into into constraints. We went really, really deep into the math with the prior question. Now we're going to go really deep into logic, and we're not going to do as much of math overall. We're still going to do constraints, but we're not going to do as much of math. We're going to do logic, and that's kind of where the beauty of GMAT Quant is. So 50 people still solving. I have 41 people who've chosen an answer choice. Can I get more people to say still solving? We have the last 3 questions for the day. 49. Okay, cool. Here is your first question. All right, guys, last 10 seconds, get those answers in. 3, 2, and 1. Let's end the poll and broadcast the results. So, choices A and C are really popular, but then we have every other choice that's there as well. Let me clear our responses. And what's given over here? Let's kind of look at this. The question is asking, is Z positive? What does this mean? Is Z positive? Is Z positive? That's the question. Is it greater than 0? Is it greater than 0? That's all we have to figure out. We don't have to figure out the value of Z. We only have to answer this question. Is Z positive? Okay. What is the constraint? Z is an integer that's given to us. Okay. And there's a second constraint, which means that says that the absolute value of Z is less than 6. Now, what does this mean? Before you even go into statement 2, one of the things with data sufficiency questions, one of the mistakes that people make is, and this is not talked about as much, is that before they go into uh, before analyzing statement 1, people do not, and I repeat, people do not look at the original question stem and extract as much information out of it, draw as many inferences from it as they should. Okay, and as someone really said, the inference that you need to draw, and thank you, Mr. Arun, is that Z is between -6 and +6, which means that there are 11 possible values of Z. Okay, that's really important. Okay, that's really important. How many of you did that? How many of you, before even looking at statement 1, said, hey, there are 11 possible values of Z, and out of these 11 values, only 5 values are positive. And we have to figure out, is Z one of those 5 values? Purnima says, but mod is always positive. Yes, Purnima, the absolute value of Z is always positive. Doesn't mean Z is always positive. Because if that were the case, then we won't have to take the mod around it, right? All right. So let's go forward. So the first statement says is Z minus 2 as absolute value of Z minus 2 is greater than 3. So, the question that you have is, can you write it like this? And the answer to that is no, you can't write it like this. Why? Because this is only true when we have a less than sign in the inequality. In the absolute inequality, we have this less than sign. So how do we go about solving this? We really say, hey, let's assume that Z minus 2 is T, and we can really say absolute value of T is greater than 3, which means T can actually take the following values. When T is positive, T can be greater than 3, and when T is negative, T can be less than -3. Why? Because -4, absolute value of -4 is 4, which is greater than 3. Absolute value of +4 is 4, which is greater than 3. Okay. So if Z minus 2 is greater than 3, then this means that it can be split into Z minus 2 is greater than 3 for Z being positive, and Z minus 2 is less than -3 when Z is negative. That's how you open the absolute value. You solve this and you say, hey, there are 2 values that are possible. Z is greater than 5 or Z is less than -1. How do you get this? You actually add +2 over here and add +2 over here, and you get Z is less than -1. All right. So what can you infer from this when you get Z is greater than 5 or Z is less than -1? What can you infer from this over here? Oh, it's sufficient. It's not insufficient. When you say Z is greater than 5 or z is less than -1, okay, so the thing is, this tells you that z can be both positive and negative, but the original statement said that, hey, z has to be less than 6. And this statement is saying that z has to be greater than 5. So essentially, the only possible value given all the constraints is that z is always negative. All right. So all values of z are negative. So when you look at the question which we had to answer, is z positive? We can say we can be 100% certain that z is not positive. So value of z is negative, only negative, not non-negative, only negative. Why? Because z is less than -1. Okay, so statement 1 is sufficient. I want you to sit back, look at this once again, and see how we utilized the constraints from the original question over here and inferred this. This is not a math skill, this is an inference skill that we are using. When we are saying there are two possible values of z, which is z is less than -1, which means z only has negative values, or z is greater than 5, but the original question stem said that z cannot take a value, integral value greater than 5. Why? Because z has to be between -6 and +6. Then you say, hey, z, there's no way in the world z can be positive. Z can only be negative, which means, hey, we can answer the question, is z positive? And the answer to that is no, z is not positive, which means statement 1 is sufficient. Now, many of you want to see the question? Here is the question over here. Here is the question. Let's just go forward. I'm going to just explain this once again. Let me just clear up the poll over here. And again, this is application of a basic concept in absolute inequalities. So z minus 2 is greater than 3, and essentially what this means is that you can really, so when you say absolute value of z minus 2 is greater than 3, when you open the absolute value up, when you open the modulus up, you can express it in two forms. You can say when z is positive, z minus 2 is greater than 3. When z is negative, we know that z minus 2, or when the absolute value is negative, z minus 2 is less than -3. That's how you open the modulus. Okay. And when you do the math over here, you get z is greater than 5 and z is less than -1. That's how you open the modulus. Now, why do you open the modulus like that? Again, look at the concept files that were sent to you. We explained that to you over there. If I go into explaining this, I'm going to spend 10 minutes doing that. Okay. And again, the concept files tell you that. That's why we send the concept files your way. Okay. Now let's look at the second statement. So statement 1 is sufficient. We know that. Statement 2 says absolute value of z is 2, which means z can be +2 and -2. Both of them are essentially possible given what was given in the original question, which means by itself statement 2 is not sufficient. So the correct answer is A. You have concept files in your email, and if you don't, just log into the e-GMAT account. It's a part of your free trial. Okay. So what's important? You've got to pay close attention to the sign of inequality, and again, be very mindful to the constraints that are given to you, the implicit constraints that are given to you in the question. That's very, very important. The next question is a 700 level question, and this question has actually even less math. It is even more logic. So select still solving. And again, guys, some of this for a few of you may seem like too advanced. Once you go through the solution, when I share the PDF with you towards the end of this webinar, you're going to find it's very simple. All right, let's get a few more people to say still solving. 3, 2, and 1. We remove broadcast results. Here is the next question. Good luck, guys. Again, there's very little math in this, pure logic in this. All right, guys, get those answers in. 3, 2, and 1. Let me end the poll and broadcast the results. Okay, the 700 level question, difficult question. Let's kind of see why it's simple yet so difficult. Now, what is this question asking? What is this question asking? The question is not asking D. This question is asking whether B is greater than A or is A less than B. The way I like to read is B greater than A? It just sounds more natural to me. Okay, that's what what he's asking, can you determine whether A is less than B, or can you determine whether B is greater than A? Is there a constraint on the values of A or B? No, there is no constraint on the values of A or B. Okay, so they can be positive, they can be negative. We don't know anything. There's no constraint overall. There's nothing much given in the question statements. There's not much that you could infer. Now, let's go to statement number 1. And again, remember, we have the question stem here. It's asking whether B is greater than A. How do I find this easier than some other 600 level questions? Let's see whether you solved it correctly, Calvin. Which answer choice did you choose? And then let's see the stats. Okay. All right, you chose D. Let's see whether that is correct. So what does statement 1 say? Let's see. How do you read statement number 1? How do you read statement number 1? Pure English, not math. B minus A is always positive? No, not really. B minus A is actually either 0 or positive. So when you say but that's good the way you're reading it. So when you say absolute value of x is y, what it really means is that y is equal to the absolute value of a number, which means y is a non-negative number. Why? Because absolute value of something can be equal to 0 or greater than 0. Does everyone understand that? That y is a non-negative number. Is that clear to everyone? That's kind of the very definition of absolute value, right? Which means y is equal to 0 or y is greater than 0. Now let's kind of take both these cases. Which if y, what this really means is that b minus a is greater than or equal to 0. Which means that b can be greater than or equal to a. Which means there are two possibilities. B is equal to a or B is greater than A. Is that clear to everyone? There are two possibilities. Then is statement A sufficient? Does this mean statement A is sufficient? No, it isn't. Why? Because the question is asking, is B greater than A? And you can't with 100% certainty say that B is indeed greater than A. Okay, there are two possibilities. B can be equal to A or B can be greater than A. So statement A is not sufficient, which means A can't be the correct answer, D cannot be the correct answer. Okay. Everyone with me so far? Let's now analyze statement 2 independently. All right, good. Okay, I'm going to go to the previous slide. I'm going to hold it over here for 30 seconds. And again, the beauty of this question is when you solve this question, you understand the whole concept of absolute value. Okay, let's go towards statement 2. So statement 2 says A divided by B is less than 1. Okay, and in very simple terms, you know, if you just really say A divided by B is less than 1, what does that mean? What does that mean? When you say A by B is less than 1, it means, no, what it really means is, it doesn't mean that A is greater than B or B is greater than A. What it means is, what one situation does it obviate? What one situation does it obviate? With this statement, what you can really say is, statement 2 implies that A is not equal to B. Okay. Yes, you can say B is not 0. That's correct. But the other piece which is there is A cannot be equal to B. Right? Because if A were equal to B, then A by B would be equal to 1. Right? Right? A is not equal to B. Not necessarily that B is greater than A. Not necessarily. Not necessarily that B is greater than A. Let's assume A is equal to -1 and B is equal to -5. Then what does A by B become? A by B is A by B is 0.2, right? Or 1 by 5. But is B greater than A? Is B greater than A? The answer is no. -5 is actually less than -1. Okay. So you can't really say that B is greater than A. Okay. So essentially, you can take two cases. If B is positive, then A has to be less than B. If B is negative, then A has to be greater than B. So essentially, with statement 2, there are two possibilities that exist, that either B is greater than A or B is less than A. But the only possibility that doesn't exist is that B be equal to A. So again, statement 2 is not sufficient. Now, when you combine both these statements, you say statement 1 says that B can only be greater than A or B can be equal to A. Statement 2 says that B can be greater than A and or B can be less than A. You combine these two and you really say the only possibility is that B is greater than A. Hence, when you combine the information from both the statements, you get to the correct answer, which is choice C. Only 5%, only 3 people chose this. It's not always C. The first question didn't have C. Okay. It's not always C. The question prior to that didn't have C either. So yes, but you can really see how just simple logic, not a ton of math, can help you get to the correct answer. Now the next question is a very similar application. So I want you to take the learnings from this question and solve the next question, which is going to be the last question today. So I think let's just uh, get that last ounce of energy and solve that next question. Okay, I want 50 people to say still solving while I explain this. So statement 1, the constraints were that A is equal to B is equal to A or B is greater than A. Statement 2 said that either B is greater than A or B is less than A. So when you combine this, the only common piece over here is that B is greater than A. So when you combine the information from both statements, you can conclusively say that B has to be greater than A. Okay, so that's why. All right, 39. Let's get a couple of more people to say still solving. All right, 40 people have said still solving. I'm going to remove this over here. And here is the last question for the day. Here's the last question. This uses a lot of learnings from what we had today, but again, not a whole lot of math. So look at this and solve this properly. All right, guys, get those answers in now. 3, 2, and 1. Let me end the poll. And I'm going to broadcast the results. Let's see how we go about doing this. Again, as I said, this is, I understand you guys are tired. It's towards the end of the session. It becomes a bit difficult to keep your focus there. But that's when, you've got to take a step back, relax slightly, and then move forward. So what's the question asking? What is the question asking? Is z greater than 2? It's a very specific range. It's not asking for the value of z. It's asking is if z is greater than 2. And that's really important to know. And you say, is there a constraint on the value of z? There is absolutely no constraint. Okay, there's not much given in the question statement. So let's move towards statement 1. Now, what does statement 1 say? Statement 1 says absolute value of a perfect square is greater than 4. Now, what do we know about a perfect square? What do we know about a perfect square? The modulus is redundant. Yes. What do we know about a perfect square, though, just to arrive at that conclusion? It's always positive. Yes, it's always positive. So square of any number is always, I wouldn't say positive, it's always non-negative again, which means the modulus has no impact. So essentially, we can really say that, hey, what this means is that z minus 2 whole square is greater than 2 square. And I want you to read this again. Z minus 2 whole square is greater than 2 square. I've actually converted 4 as 2 square, which means you add a minus 2 square on both sides. You actually get this in the form a square minus b square is greater than 0. Everyone's over here? Everyone's till this point? Yeah. A square minus b square is greater than 0. All right, then you say, hey, this means z minus 4 multiplied by z is greater than 0. That's what this leads to. Is everyone with me till this point? When you simplify this? Is everyone with me till this point over here? Z minus 4. All right, which means that z can have two possible values. Either z can be negative or z can be greater than 4. There are two possible values of z. Okay, which means statement 1 is not sufficient. You guys with me? Statement 1 is not sufficient. Why? Because z can be negative and z can be positive. Okay. Z can be less than 0 or z can be greater than 4. How is z less than 0? Can I explain? This is actually the first question that we did, if you think about it. In the foundational skills, if you look at this inequality, and let me just clear this up over here. If you look at this inequality, and got it, good, perfect. The very fundamental question that we did, the first 6 questions, which are which are stated as the foundational skills. Now, let's look at statement 2 over here. What does statement 2 say in pure English? How would you read statement 2? Z is either equal to 0 or z is positive. Okay, statement 2 says that z is greater than or equal to 0. Okay, not always positive, it can also be equal to 0. Is everyone with me? That's just the very definition of absolute value. Okay, so there are two possibilities, either z is positive or z is greater than 0. Clearly, statement 2 is also not sufficient. Now let's combine the two statements. Statement 1 said z has to be negative or z has to be greater than 4. Statement 2 said z has to be equal to 0 or z has to be positive. When you combine both these statements, what do you get? Z is greater than 4. Okay, which means together they are sufficient. Okay, which means choice C is the correct answer. Now, where did you make a mistake? Statement 2, okay, did not interpret statement 2 the way it should have been interpreted, equating when combining. No, you shouldn't guess. Please don't guess, AD. Okay, you didn't think about combining them correctly. All right. Interpretation of statement 2. Did not solve statement 1 correctly. Statement 2, it did not interpret statement 1 correctly. Okay. Let me just go back to statement 1 once again. This is statement 2. Here is statement 1. Statement 1, focus on this expression. Okay. Focus on this expression over here. All right. This expression says product of two numbers is positive. When can this product be positive? Again, when both of them are negative or when both of them are positive. Both of them are positive when z is greater than 4. So this is the area when both the expressions are positive. What are the two expressions that I'm talking about? Let me just remove the annotation. This is expression A and this is expression B. Okay. Can't we square both sides of statement 1? You can't. No. Minus 2 square is 4. Does it mean minus 2 is positive? Gaurav, does it mean minus 2 is positive? Okay. Gaurav? No, it doesn't, right? Yes. So that's kind of the same reason. How did you get this over here? This is simply a square minus b square. So how did you get this? Use the formula a square minus b square is equal to a minus b multiplied by a plus b. You combine these two and you get z is greater than 4. Okay, and statement C is sufficient. All right. So the thing that I want to make sure that you understand this. First of all, what did you understand from all the questions that we solved in this webinar? What did you get from all the questions that you solved in this webinar? Okay, guys, I'm going to give you the PDF for the last question, so you are going to get it. Don't worry about that. If you've gotten all of this, it's way more logic than actual math. Okay, it's way more logic. It's not the math. You understand, and the beauty of this is understanding logic is easy because you're really good at logic. You may have left math some time back, but you still use logic in your day-to-day life. You've got to pay attention to the constraints, check the details. And again, I can take a few questions in which shortcuts work, but that's not what's going to get you a high quant score. Okay. And how many of you are looking for How many of you are looking to actually have a well-defined study strategy to ace the GMAT? How many of you are looking to have that? If you're looking for that well-defined study strategy, you can. We have some slots open where we do advise a few people on building their study plan, on helping them define their constraints. Uh, you can book a slot over here, or let me just go into the notes pane, and and if you go to this link, if you go to this link PSP home, you guys should be able to do this. Now, what's a good score required for LBS? You can really get this over here. We have some stats for London Business School that you can really get over here. But again, GMAT Quant, a lot more of logic than math. And that's kind of where, people who are really weak in quant are able to get really good scores if they focus on the right things, and people who are really strong in quant sometimes get stuck at a Q48. And here's an example of this guy who was very, very strong in quant, uh, 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 but essentially he struggled, and he was not able to go beyond a Q48. He realized that it's not about the math, it's about following the right method. He said, for example, uh, uh, I never knew that I could keep the variables till the end without substituting to make the problem simpler, or to stop your calculation and move to options. And that's really important. Where you're essentially looking at this and saying, this is not there to be solved. In the absolute value questions, some of the DS questions, had you tried to look at them from a math perspective rather than from an English perspective, you would have gotten so many cases that uh, uh, that overall you would have taken a ton of time solving this, and you would not have come to a certain conclusion. So that's knowing that is really important. As an example of a guy who improved from a Q45 to a Q49, he received an admit from Wharton. He also scored a 98th percentile on verbal overall. And again, very, very similar stuff. The only thing was he had a slightly stronger foundation. But again, he was stuck at a Q45. And the reason he was unable to improve beyond a Q45 was because, again, he focused on the math. He lacked the methodical approach. And once he got into the methodical approach, once he started applying constraints, he avoided those repeat mistakes. Okay, and then he also used data to isolate his weakness. How did he do that? He used quant scholaranium in doing that. Got admits from a bunch of schools, by the way. He's a guy who improved from a Q30, which is the 20th percentile, to a Q45. And again, the key for him was to start from the very basics and then move forward. Now, in this webinar, we did the same thing. We started from the very basics and then move forward. And you can really see that there's a progression as you go from sub 600 or actually 500 level questions to 700 level questions. The concepts remain the same. The habits change. You have more constraints. You're reading stuff more in a logical fashion than in a pure mathematical fashion. And as you guys move forward, you made mistakes in solving simple questions early on, but as you move forward, you guys did most of the math correctly. Okay, and here's a guy who improved from a Q38 to a Q50. Again, he got into Wharton. But with a Q38, he had absolutely no chance in Wharton, where it's a very quant focused school overall. So, to ace GMAT Quant, focus on learning the methods, focus on adopting good habits, focus on attributing causality over there, and essentially log into the free trial, watch these video lessons. Make sure you're methodical. Don't rush through questions. One of the worst things you can do in quant is rush through questions. Questions will not be overly calculation intensive. Okay. And as you become an active reader of the question, your comfort level with the question will improve, your confidence will improve, and you're going to find you're going to solve more questions correctly. The other thing is, as you solve good questions, you're going to start trusting the test maker. You're going to really start trusting the fact that, hey, you're not going to get something that's uber difficult that requires a ton of calculation. Most of you have the skill set needed to solve every question out there. So with that, good luck. And as next steps, review everything in the free trial. And there are a few other questions which are there in the PDF, solve them, and also solve questions in Scholarium. Let me share the PDF with you. Here's the session presentation. If you could give me some feedback, that would be great in the short answer part. And if you have any question still, I'd be happy to answer that question. Am I isolated? Yes, in many ways I am isolated. Yes, we are all working virtually. So, so yeah. In fact, our CTO has written uh, this post about how do we work virtually. At e-GMAT, we started as a virtual company, so working virtually is not something that's alien to us. Our first 5 years of existence, everyone who we hired, because I'm in Phoenix, Arizona, um, uh, or rather, both Pyle and I are in Phoenix, Arizona. That's why uh, 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 we hired the first 20 employees virtually. So in fact, if you read this blog post that was written by our CTO, you can really see how we are working virtually. Natalia has a question. If you're on a mobile device, you won't be able to download the PDF. If you're not on a mobile device, you should select Algebra 2 and click on Download Files. Okay. Um, do we have 700 level question bank? And yes, we do. Yes, Natalia, we have the world's most exhaustive GMAT course that you'd rarely see. Okay. If you have doubt on the last question, take a look at the PDF, and you still have doubt, write to me. I'd be happy to help you with that. Let me actually see if I can give you the link to PDF over here. Just give me 1 second. I can probably upload the PDF on our blog and give you guys the link. Uh, all right, getting the PDF for you, for those of you who are on a mobile device. The PDF should be in your inbox in another 10 in the Q&A pod in another 10 seconds or so. It's almost uploaded. And again, we'll be sending the recording in another 12 hours as well. So here is the PDF over here, Aruna. You can download the same over here. And again, for those of you who are asking about the study plan, Here is the study plan over here. Okay, guys, where is the PDF? The PDF should be there in the Q&A pod, um, essentially. So I just shared it with everyone. So if you look at the Q&A pod, which is the bottom left-hand corner, you should be able to see the link to the PDF. Is the link to the free trial on your profile? Yes, it's there if you are, you log into the free trial as soon as you sign into e-GMAT. If you still need the PDF, do let me know. You ask the question in the Q&A pod so that I can share the link directly with you. Otherwise, here is the link to the PDF, but it's very difficult for you to be able to copy this. Actually, I can also put the link to the PDF over here. And this is something that you guys can copy it over here. All right. Do we have live lectures, Natalia? No, not yet. We used to have live lectures, but no, we don't have live lectures today. It's just that we found many people didn't need them, but essentially we address queries, doubts on our questions through our internal forum. So overall, every entity within e-GMAT has its own dedicated doubt solving forum. If you have a question, post those questions in the forum, and we'd be happy to address them. Our SLA around those is about 24 hours or less. All right, guys. Any other question? If there's no other question, then thank you for joining me today, and I'll see you guys on egmat.com. Good luck and happy learning, and stay safe.